Now, let us look at some of the possible ways in which we connect the DC converters. Yeah, and note that say we will use the line explicitly whenever there is a line, and many times we use the link when there is no line, and sometimes we use the word link to mean both ways, whether there is a line or no line. Okay. So, link, DC link is something which is used as a common word for both cases, whether there is a transmission line or transmission line is not there. But whenever there is a line, we explicitly state that there is a DC line. Okay. So, link is a very common word. DC link means line may be there or may not be there. So, there are different types of DC link. So, let us look at a few of the types of DC link. The first type is monopolar link. So, what I will try to do is I will show only the schematic diagram, I will not be showing the circuit diagram. It is unnecessary and complicated to show circuit diagram. I will just show a schematic diagram. So, the schematic diagram is like this. So, this is a schematic diagram. I shown one rectifier here. There is a transformer, and in a box I have shown a thyristor. Now, this transformer, say all of you are familiar with this symbol of transformer, right? This is one of the symbols used even in single line diagram that you are more familiar with. So, there is a transformer with a box with a thyristor. Now, this is a representation of what is known as a 12 pulse converter. Okay. So, if you look at a 12 pulse converter, there is a YY and Y delta transformer. There are two transformers and two 6 pulse converters. So, that entire arrangement is shown as one transformer and one box with a thyristor. So, this is the schematic representation of a 12 pulse converter. So, I have two identical 12 pulse converter, one on the rectifier side, one on the inverter side, and I have shown a wire in which a current ID is flowing, and I have marked a minus sign here. Okay. So, what I am trying to say is, by minus sign, this is the negative terminal of the DC side voltage. Now, the other end or the other terminal is the positive terminal. Suppose the rectifier and inverter are actually, they are actually away from each other. There is a distance of the order of say few hundred kilometers between the rectifier and inverter. So, there is only one conductor which is the negative terminal. Okay. There is only one conductor which is at the negative potential. The other terminal is actually grounded. Now, where should the current flow? Say if the current has to complete the path. So, ID is flowing in one of the conductors. So, the other terminal, which is positive terminal, is actually the ground. So, the current is getting completed only by flowing through the ground or water, in fact. Okay. So, this link has only one conductor. So, just one conductor alone will not serve the purpose of current flow. So, I need to close the path. So, it uses ground or water return, ground return or water return. So, if it is for the purpose of underwater transmission, the water itself is used as a path for the return current, and very rarely metallic return is also used, which is buried. Sometimes metallic return is used. The question is, why not make conductor positive and ground negative? Conductor is usually negative. Since corona effects are substantially less compared with positive polarity of conductor. So, this is one type of link, monopolar link. We will look at there are many types of links, but in this course we will look at only two other types. One is bipolar and another one is homopolar. So, we will look at those details in the next class.